I know some of you could. I see that you found a sheet that I put on your desk, and you're not going to need to look at that right away. So you can put your pencils down and put your eyes up here on me. And I want everybody to concentrate on this pen. Watch the pen. Notice your eyes are getting heavy. Keep watching the pen. And soon you'll be under my mind control. Okay, does anybody know what I'm holding? Does anybody know what this object is that swings from? Do you know it, Sylvia? It's called a what? It's called a string. You're absolutely right. Well, it has a string attached to it, but the string is doing something. It's going back and forth, back and forth, back and forth. It has a special name. Are you Jackson? Yeah. Jackson, do you know what this is called? This is a letter E. Oh, you're in the right neighborhood because you're thinking simple machines, and it's not exactly that. It's not exactly that. Adam, do you have a pendulum? That's exactly. Can everybody say that word? Pendulum. And we're going to look, and our lesson today is going to be focused on how force acts on a pendulum, because we've been talking about force and motion in science over the last week, and so we're going to be looking at this special kind of thing called a pendulum. And but first, let's take a look at the standards we'll be talking about. All right, the standard here, and you can just kind of read along with me as I read it aloud to you. It says students will demonstrate the relationship between the application of a force and the resulting change in position and motion of an object. So what object do you think that we're going to be examining today? What was that called? A pendulum. What was the object again? A pendulum. Exactly. And our language objective, okay, this is what I'm working on. Students will be able to describe the motion of the pendulum both orally, which means out loud, and in written form using key vocabulary. So we're going to be learning some of the vocabulary today in just a few minutes. So our EQ says, how does force affect the motion of a pendulum? So we're going to be taking a look at this site and get some background information about pendulums and how they work. All right, and this is kind of a cool, you might have seen this before, this PBS Kids site. They have cool activities, so check it out sometime at home if you can. So the pendulum, word pendulum is a noun, and it's a 3-syllable noun, pendulum. But it comes from the Latin word that means hanging. What does it mean? Hanging. All right, do you see why it means hanging? Yeah. Because it's got a string and it's got an object at the end of it, exactly. So it says a pendulum is made by hanging an object from something else. When you pull the pendulum to one side and let it go, it swings back and forth, and back and forth, and back and forth, okay? It says you can find pendulums in grandfather clocks. Raise your hand if you've ever seen a grandfather clock and know what I'm talking about. So here's a picture of one, and that's the pendulum right there. And the pendulum actually is used to keep time, because every swing, it's the same amount of time for every full swing. Okay, so that's where you see them in real life. Can you think of any other places maybe where you've seen a pendulum in real life? What do you think? What's your name? Harrison. Harrison. Where else have you seen a pendulum?
Like those marble balls.
Oh yeah, well exactly. I had one of those when I was a kid. It's that marble ball thing, and it's kind of like, I think they have some magnetism about them, which makes them work, okay? All right, so let's see what makes a pendulum swing. So it says when you first hang a pendulum, it hangs straight down toward the ground. To make a pendulum swing, you have to pull it, okay? Now what do we learn about pulling something? What is that called? What's a pull called? What's it called? Tell me your name. Ruby. What's a pull called? What do we know that a pull is?
A pulley?
Well, a pull is certainly, yeah, we see pull forces in pulley, but a pull is a type of what? Force, exactly. All right, so you have to pull it to one side and let go. But as you pull it to the side, you're also pulling the pendulum up a little bit. And when you let it go, gravity, the force that pulls objects toward the earth, pulls the pendulum downward while the string moves the pendulum to the side. Then when the pendulum gets to the middle, it keeps swinging and goes up on the other side. The pendulum will keep swinging back and forth for a little while, but pretty soon it will stop. That's because forces like friction and air resistance slow it down, okay? So first of all, what was that force that is pulling that pendulum to the earth? What's that force called? What's your name? Yeah, Jalen. What's that force called that pulls everything toward the earth? Gravity, exactly, okay? Now what is that? What's that force that's making the pendulum slow down over time? What's that called? Are you Gretchen? What's that called that makes the pendulum slow over time? What did it say?
It's air.
Air resistance or friction. We can think of it as friction, a force that makes things stop. Okay? All right, very good. Now, what we're going to be doing is we're going to be experimenting with two sizes of pendulum. So let me go over here. Here's the configuration is a little bit different. So let me get out here. Go back here. And so take a look at that sheet that's on your table, if you would. Go ahead and put your name on it if you have it. And on one side, of the left-hand side of the sheet, it's going to talk to us about how we're going to time this pendulum. And on the right-hand side of the sheet, there's a place where you're going to be recording the data. So we're going to be taking a look at that and seeing what your part is when you get your pendulums and you work with your group, okay? So I've got my copy up here. You follow along on your own paper, okay? So what the first thing I need for you to do, okay, we're going to look at, I've already built the swinger for you. I've already done that part, because that takes a long time, and we don't have that long. So our part is going to be part 2, which is timing the swingers, okay? Now you are going to be testing out the length of 2 different swingers or pendulums, and we've got one that's 10 centimeters and one that's 20 centimeters. So if you would, just scratch through the whole line that says 30, okay? We just don't have time to do all 3 lengths. So just scratch through that box on your table and just show me the thumbs up when you've done that. All right, excellent. This page is on it. Ruby. Super. All right, everybody there? Okay, we don't have to fill, we don't have to color it in. It can just be a simple line just through it right there. Okay. Now, another thing I want you to add to your table, because good scientists always do things more than one time. They always repeat something. Why do you think maybe a good scientist needs to repeat an experiment? Why do you think, Melissa?
Because if it's really true, then it needs to happen to you.
Yeah, that's right. That's right. Well, sometimes, you know, and I'm going to show you why you're going to need to repeat this, because we're going to need to be real exact about how we release the pendulum, how we count and use our clock. And so if you mess up one time, the data that you get just may not be accurate. That's why we do it several times. So what I want you to do is I want you to write a 1 and then a 2 and then a 3. And we're going to do 3 trials, okay? And what you can do is you can put a line, just a light line, and just to separate that. And then that means that we're going to put the first time that we swing it, we're going to put our data in this part of the chart, and then we'll do it again, and put the data there, and then we'll do it a 3rd time in this part of your chart. Okay, everybody with me? Okay, so I'm going to show you how you set it up, and then we're going to get organized in groups of 3, and then you're going to try it yourself, okay? So the materials that you're going to need for this, and somebody's going to get some for each of your groups. You're going to need a pencil, and this is the thing that the pendulum is going to hang from. And watch what I do with it. Okay, so watch. Everybody eyeballs this way. I'm gonna put it. You're gonna use your desk, and I'm gonna put it up here so you can see. You guys can see a little bit from back there. All right, Lily, you with me? Okay. So I'm going to put my pencil here. Notice I'm going to put the eraser side out so my pendulum doesn't slip off. And then I've got a piece of tape, and I'm going to put the tape this way so that what's not going to happen now?
It's not going to fall.
Well, my pencil's not going to fall off, right? And then what you're going to do, okay, this is a pendulum, and this is the 20 centimeter length, okay? So the 10 centimeter, do you think, is it going to be longer or shorter?
Shorter.
It's going to be shorter, exactly. It's going to be half the size, exactly. So this is the 20 centimeter pendulum. And notice it has a loop right at this end. And then I put a penny inside this paper clip. And the penny is like my bobber. It's gonna have a little weight, right, to help gravity. Because if I just had a string, it's not really gonna build up any momentum to move back and forth. So then I'm gonna put my little loop over my pencil right there, okay? Not too close so it's gonna bang in here. And then a counter, the timer is gonna watch the second hand of the clock. So everybody look up the clock, and I want everybody to identify that the second hand is which hand on that clock? It's the red hand, okay? It's the one that's counting 60 seconds for every minute, okay? So what the goal here is that one person is going to be the timer, and your eyes are just going to stay focused, and you're going to be counting the seconds. There's going to be one person that's going to be releasing the pendulum. And look how I'm holding this, because you're going to need to know this. Okay, Caitlin, look this way. Direction this way, please. So you're going to need to hold your pendulum level to the top of your table. See that? It's in a straight line. Okay, we've talked about angles, so you're going for a straight angle here. And then when you're ready, your timer's going to say go. And you're going to help me, Caitlin, okay? So you want to be my counter. And what we're trying to do is we're going to count 10 swings. Well, a swing means it goes this way, and then it goes back. That's one swing, okay? So who can be my timer? How about two people over there can watch my time? And we're going to test this out. And Caitlin's going to help me count since she's right here. All right? So right here, so Caitlin, remember, back and forth. Once we get to 10, you say stop. And then you tell me how many seconds it was, okay? You guys ready? All right, timers, eyeballs that way. Oh, look at what it's doing. Did you see that? I know, mine's going crazy like that. I don't know why it's choosing right now to do that when we're trying to use the second hand. So clock, you need to cooperate. Okay, Caitlin, you ready? All right. Timers tell me to go. Here we go. You don't let me tell you something, timer. You don't have to wait until it gets to the 12. What you can do is wait until the thicker part of the second hand gets to one of the numerals, like 1 or 2 or so forth, and then start counting from there. Because a second is a second no matter where you started in the clock, right? Okay, let's try it. You ready? So when you get to the next good numeral, tell us to go.
Oh, so now it's deciding to freeze up.
2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. All right, timers, how many seconds? How many seconds was it?
10.
It was 10 seconds. Okay. Now notice this was banging just a little bit. So we will probably want to stick the pencil out a little bit further, maybe about that much, so we don't have that same kind of problem. Okay. We don't want to go too far out where it's going to be a bit tippy.
A little bit fast.
Okay. So everybody follow. Everybody see what you're going to do.
Yes.
And once we get our materials and you get set up, I'll be circulating around in case you have any problems. Okay. So the important thing, so what I would do is, and after that trial number 1, what am I going to write right here?
10.
I'm going to write 10, exactly, because it took me 10 seconds, and that's my unit of time right there. It took me 10 seconds for 10 swings. Does that make sense? Okay? All right, so, now we're going to count off in groups of 3. And I want to show you what your jobs are. I'm going to make this easy so you don't have to guess once you get your material. So if you're a number 1, so remember your number when I give it to you. If you're a number 1, you're going to be responsible for coming and picking up the materials. If you're a 2, you're going to be watching the second hand. If you're a 3, you're going to be counting the swings. All right, everybody follow? All right, so any questions so far? All right, yes, Jackson.
Who's going to let go?
That's a counter. And actually there's another person too. So that materials person's right there and you both can count. Because once the materials person comes over here, that materials person is going to be watching too and you both can be counting. Okay? So just one person needs to watch the clock. All right, everybody good? Okay. So I'm going to start counting. Okay, you're a 1. Got it? 2 and 3. Okay? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, and I'll jump in with you. Okay? All right. If you are a number 1, hold your finger up. Okay, number 1, come on, see me. Okay, you need one piece of pencil, a piece of tape, a penny, a small one, 10 centimeters, a long, okay? Ready? Pencil, tape, 10 centimeters, 20 centimeters. Got it? Pencil, okay. Yeah, who do you go with? Right over here? Right over there? You got it? All right. Okay, grab one of these, one of these, there's a penny. You don't have to put it. That's 10 centimeters. That's 10 centimeters, yeah. I think I drew one short one.
Ace is 1, I'm 2.
I'll do it at baseball. Okay. All right, we short? Yeah, wait, here you go, 10. Here's a 20.
Because there's no one sitting here.
So Corey, I'm okay with the trick.
So you will stay
You're at 3 right now.
Why don't y'all just rotate his swings? Rock, paper, scissors.
You can't
I know, but write your first trial down. Write it down. Yeah.
Write that the counter counts as how much
Who's y'all's timer? Adrian, who is y'all's timer? Well, turn around and look at the clock, sweetie. He's ready to go.
I'll say go. Wow, 16. The camera is to
No, Kimura tells you when to go, honey, because she's doing the time. Y'all, wait a minute. Adrian is the one who says stop. So, well, no, I take that back. Corey, if you're the counter, when it swings 10 times, that's when you say stop. And then you say how many seconds that was.
Yeah, we don't need scissors.
No, do it again. Remember, 1, 2, 3, 4. Okay.
So once you get that seat right there, it's a little spot. You can jump.
Write it down. And Adrian, hold it down level with the desk.
You were looking at okay, I'll get the next one.
You're supposed to be watching the clock. He's supposed to be watching the penny. Write it down, somebody. Write it down.
Okay, guys.
She's busy working with my ESOL kids and I'm busy taking.
Stop!
Looking like he's doing it. Yeah, he wants to be.
You count it.
I knew something happened, but I didn't know what it was.
Okay, but anyway. Did y'all hear me? Y'all ready to go? Y'all, they don't care. They are creatures of routine. I don't care when I come in. You ready?
All right, how are we doing over here?
Stanley, is everything on the screen?
Yeah, like that. Awesome. All right, let's see what you find. All right,
said you
12 seconds, 6 and 9. Okay, so you said your long one over here.
Come on, Ryan.
All right, are you the only one working? Try it, helping you.
Oh, shit. Go. And on time. But when I give you the thumbs up.
Oh, a wrecking ball.
I'm sorry. I didn't know. Tim. Go. What do you got?
Hey, everybody, freeze for a sec. Freeze. Oh, freeze. No sound, no movement. Lily, that means you. Ice cube. Now, I'm going to give you guys just a couple more minutes because I know some groups have already finished their 3 trials for each size of their pen. So I'll turn the light back on. I'm going to give you about 3 more minutes and then we're going to take a look and see what we have to do with those numbers, that data, okay? So 3 more minutes. Oh, okay. So you're gonna do. Have you done it all? Okay. So the next step is to find what's called the average. Find the average. So what you do? Because we don't know which is the most accurate.
We just went to the bathroom. You went in the bathroom. You went in there.
So you don't have to find the average because it looks
Is
like
something wrong with your stomach?
all the variables match.
Is something wrong with
What
your
about
stomach?
this case? What would we do? Because the numbers are all different.
No, you don't. You just have to have a break.
They are close. They are close. However,
Not during Miss Flexner's lesson, honey.
you can try it one more time, and I'm going to show you how you're going to get it.
We're talking about the class.
All right. How are we doing?
You did that, honey. You did that. Okay, so just probably there's gonna be some questions down on the bottom. But don't move ahead because I'm not real sure what's coming next. Okay.
Like you're counting. Okay, you're really
Can't you see it from back here?
At this time, would you please find your seats? And if you were the materials person, I would like all the materials walked over and placed on the table. So number one, a pencils, pieces of tape, and a pendulum. Walk back to the table, please. Miss Taylor, I must say, your group follows instructions very nicely.
Well, thank you for that.
All right, Caitlin, go back. So you got a pencil over here. All right, that's fine. We'll do it. Don't worry about that. Just put all the boxes in one. Put all the pencils in the pile. Put all the things in the pile. No, in the correct. Thank you. You are ready. You guys did a nice job with your material. All right, thank you guys. Okay, we're now ready for some math. Yay! All right. So we collected this data, but now we got some numbers. What do we do with them? Because for most of you, when I looked at your chart, you had 3 different numbers in each time you swung your pendulum. So what you're going to be doing now, you're going to do a little math, and trust me, it's not complicated, okay? So I'm going to show you how I'm going to do a set of numbers, and then you're going to do them for your 2, the 10 centimeter and the 20 centimeter, okay? So what we've got to do is we've got to find an average. And an average means that if we repeat something a number of times, we're trying to find, if we did it over and over and over again, what is most likely going to be the number of seconds it would take for this pendulum to swing 10 times? What's most likely? What can we predict? So in order to do that, let's see, I want some real data. So how about you, if you would, tell me your name. All right, Timothy, you did an excellent job, by the way. We're doing a really good job controlling your pendulum over there. Give me, if you would, what you have for 1, 2, and 3 for your 10 centimeter pendulum. Okay, 10. Oh no, okay, so he made it easy for me, okay? So what would happen, I'll demonstrate what you do with this, okay? So what you do is, to find an average, is you take 10 plus 10 plus 10, and this is going to be too easy, so I'm going to have a harder problem. And when I add the 3 tens, what do I get? I get 3, okay? Now, this is going to be easy mental math because I have 30, and now I'm going to divide it into 3. So what am I going to get? 10. So my average number of seconds for swinging the 10 centimeter pendulum, of course, is 10 seconds, okay? So that was easy. Now, what if the numbers are different? So can somebody give me an example of 3 numbers that look different for your 20 centimeters, because we've got to make this harder. Lily?
9 seconds, 12 seconds, and 2 seconds.
All right, so 9, 12, and what was the third one?
10.
10. Okay, so now, who remembers what we have to do? These 3 different data points. Now listen what we did. We added together, okay? So Lily, if you haven't done this, go ahead and do it now. So I'm going to add 9 plus my 12 plus my 10. And when I get that, what do I get? I get 31, okay? Now, if I divide that into 3, am I going to get a remainder?
Yes.
Okay, all right, just checking out here. I will. So what's most likely? I can say, well, 31 divided into 3, I know it's going to be close to 10, but it's going to have a remainder. So I'm just going to use 10 as my average here, okay? So I would put 10 here. Now, this is kind of interesting because they're both 10 seconds. They both took them 10 seconds. And would you expect that for pendulums that are 2 different lengths like that? Okay, so what I want you to do right now is go ahead and find your average real quick for both of them. Go ahead and do the math calculation. If you haven't already, so add or finding the average. Find the average. You got your sheet? More, where's your pencil?
7 seconds.
Okay, so you're finding that. Yours was easy. Did you find the other one? Put that over there.
So 7 plus 7 is 21 divided by 7.
Okay, so Sylvia,
And then 10 plus 15 plus 35 divided by 3.
you're on it. Okay, Liz, you got 5 averages.
31 and 2.
Okay, so Matt, you got your averages.
No, wait, no, I'm not 36. It would be 30. Wait. 35 divided by 15. No, that's 36. So it would be 11. It would be 11 seconds.
Alright, did you find it? Did you get your average? Okay, what about yours? You had 11 and 11. Is that
It's 35 10 plus 10 is 35.
Did you find your average? It looks like you're working on that one. Did you find that? Alright, did you get it? Adrian, did you find your average?
It was 10.
Alright, if you would, just show me if it comes up. Alright, good. Thank you, Sylvia. Sylvia is ready. Thank you. Okay, let's turn our voices off just for a second. We're gonna have to wrap this up for just a minute. But I'm curious. So, let's hear some averages for the 10 centimeter. I'm gonna write this over here. Let's hear some averages. What do we get? Okay, so here's our 10 centimeter pendulum, and here's our 20 centimeter pendulum. And let's hear some averages. Okay, Asa?
7 seconds.
So 7 seconds. Okay, give me another one, Gretchen. 6 seconds. Okay, 6. And maybe one more. What's your name? Jemai, give me yours. 8. Okay, that's interesting. Okay, so we have a 6, 7, and 8. And so it looks like if we took the average of these, we might take that middle number, and it looks like if I looked at these 3 data points, that 7 seconds might be the average here. Let me have 3, really, let's hear from 3 different groups. Let's hear some averages for the 20 centimeters. So Harrison, give me your 11. All right, let's hear a different number. Let's hear it. Yeah, let's see. Tell me your name again. Jalen. All right, Jen. 10. Okay. And let's hear another one, Jackson. Oh, well, wait. Are you in the same group? No. Oh, okay. You're in a different group, so that's good. Okay. So for this, the 20 centimeters, does it look like it took longer for the 20 centimeters to get the 10 swings? Now, who can explain why that might be? Why would it take the 20 centimeter pendulum longer to make 10 swings? Okay, so think about using some of the vocabulary that we've been talking about. Why would that happen? Okay, Melissa, you start the discussion out for us. Why do you think?
Because there's more length in the string, so it takes like a longer around it.
Oh, this is how we're using math language. She's saying it's a longer swing. She talked about perimeter. Think about that that tool in math called a protractor that measures angles. I'm thinking, doesn't it seem kind of like it was forming kind of this arc? Okay, what else? What other insights do you have, Ruby?
Well, when we were learning about planets, the ones that were close to the sun were going faster than the ones in Alpha.
Wow, what a connection you just made. That was really stunning. Do you understand what she just said? Remember, think about planet Mercury. Planet Mercury is the closest one to the sun. So think about old planet Mercury. Okay, here's the sun, and planet Mercury is just going here, as fast around, right? But say you're out there where Neptune is, and what happens?
It takes you a longer time to get around the sun.
It does, because there's a longer circle, a larger circumference that you have to make. So do you think the same thing applies when you're talking about swinging a pendulum? All right, very good, okay? All right, so for your final thing for me, this is a ticket out the door, and we got to wrap this up. There's a question that I want you to answer, and you can just use the back of your sheet and to do that. So, let me get this. I'm always trying to figure out the best way for this to work. Okay, I'm going to say yes. Oh, and I don't really want to say this changes. I take it back. Cancel that. And we'll get rid of that. Okay. All right, so here's your question. I want to see what your thinking is now in writing. So the question, if you would, follow me while we read it off the board. It says at the bottom of your recording sheet, so the bottom or the back, if you have some room, notice there's some room at the bottom. Was there a difference in the number of swings between the 10 centimeter and 20 centimeter pendulum? How can you explain the difference? Okay, so we just kind of talked about it, and let's see your thoughts in writing. I provided a couple of thinking steps for you if you're kind of stuck on how to begin this. And there's also a word bank with some key words. Okay, let's look at the words again, Lily. Let's all read them. First one is pendulum. Second one is resistance. And then is gravity. There's mass, and we didn't talk about that, but that has to do with the weight. And you can think about the penny providing the mass or the weight. We talked about push, pull, and friction. Okay, so you can borrow any of those words from the word bank if you need to help explain your thinking. And you can start your sentence like this if you need some help. It says the difference in the number of swings between the 10 centimeter and 20 centimeter pendulum was blank. So here, where am I finding the difference? Well, I'm kind of looking at my average, right? And I might say, well, 10 is the average here, and 7 is the average here. So the difference is what between the 20 and the 10? What would the difference be, Sylvia? The difference, remember, think about finding the difference, you're using subtraction. So if I found the difference between these two numbers or averages, what would the difference be? Well, let me think. So if I'm on a number line real quick, and I'm at the 7 mark, and I got to jump over here to the 10, how many jumps am I going to make in I'm going to go 1, 2, and what? 3. So that's simply just saying 10 minus 7 equals 3. Okay, everybody follow? Okay, Washington, did you get that? All right. So the second part of it says, I think the difference can be explained because, and this is where you're talking like Melissa and Ruby are talking about those amazing connections about maybe length of string, maybe there's some friction involved. Okay, all right. So I'll give you about 2 minutes to do that. Everybody know what you're doing? So you're telling me, why is it that the longer pendulum, the 20-centimeter pendulum, took more seconds to make its 10 swings? Why do you think that is? That's what you're explaining. You got one? You got something? Can I see it? Oh, wait! Oh, you put it down here. Oh, my glasses. Can you read that to me? Yeah, can you read that one? Oh, okay. My mistake. It's always been like that. Good. And then what did you say? Was 3. And then what's this part saying? So what forces were acting on the pendulum? Gravity. Yeah, see if you can figure out a way to work that into your explanation. Do you think you could? All right. Does someone have what they think is a complete answer and maybe even use 1 or 2 words from here to help explain it in really good scientific terms? Okay? Jackson, let's hear it.
This, because 3 centimeters as a shorter swing, like a shorter stroke. And the 20 centimeter has a long stroke.
So what was acting? Let me think. There's some extra forces acting on the 20 centimeter string that weren't acting on the 10 centimeter string. What do you think? You think that was there added gravity perhaps? What about the resistance? Friction. Ooh, see if we can work that in. But you know what? I'm going to brag on him for a second because he even drew diagrams. I'm very impressed with that. So he's kind of drawing out his thinking, which is a really, really good way to solidify your observations. What else?
String had more mass.
Had more mass. Excellent. So it had a little bit more mass. Maybe the added weight of the string, perhaps. Okay. What else? I mean, other than the length of the string, did anything else change about the pendulum itself? So there was definitely added string. You're absolutely right. Do you think the weight of the penny, did that change? The weight of the paperclip, did that change? No, that didn't change at all, okay? But that's good. So you worked in an idea about mass could have been different slightly. Okay, Lily, you're dying, yeah.
The difference in the number of between the 10 centimeter and the 20 centimeter is 1. I think the difference can be explained because of length. The 10 centimeter is smaller than the 20 centimeter, and the 20 centimeter is bigger than the 10 centimeters. So the 20 centimeter pulled the mass down, and the 10 centimeter was pushing it.
Oh, good. Okay, so you managed to work in a lot of the words. Nice, nicely done, and you're very complete thought on that, Lily. Okay, nice job. Well, you guys, we're going to call this a wrap. Thank you so much. This was a much nicer experience working.